everyone, Anthony Silva here, back for another problem for the LeetCode 150 walkthrough on LeetCode. So I'm starting up a new set of problems today. So in the last video that I did, I finished off the arrays and hashing problem set. So today we're going to be starting off with the 2 pointers problem set, and it's going to be the valid palindrome problem. All right. So let's take a look and read this problem statement. So a phrase is a palindrome if, after converting all uppercase letters into lowercase letters and removing all non-alphanumeric characters, it reads the same forward and backward. Alphanumeric characters include letters and numbers. Given a string S, return true if it is a palindrome or false otherwise. All right. So example 1. We have a man, a plant, a canal, Panama. Okay, so the output is true. Now, it's not look true, but why is it returned true? Okay, so notice a couple things with the explanation. It looks like we don't have to worry about the cases of letters here. So if we were to say that the lowercase forms of each character are equal, then we could like move forward with the whole thing, or maybe if it were uppercase, depends on what you like basically. And then notice that the punctuation and the spaces are not being included in the explanation either. So it's only the letters here. Okay? And not what numbers it says in the problem statement. Race a car. Okay, so that one was going to be false because we have R and R, A and A, C and C, but we have E and A. So that is definitely not. So if we were to combine the letters into a single string, that is not going to be a palindrome. So the answer is going to be false. All right, and then the last example is simply going to be one space. All right, so the output is going to be true because S is going to be an empty string after removing non-alphanumeric characters. Since an empty string is going to read the same forward and backward, it is the palindrome. All right, and then all right, so the string is not going to be empty, but we could still get a string that is just spaces here. So we're going to need to factor that into account when we try to look at the strings we're going to use. Oh, it looks like they might be significantly large too. Not as large as like in the last problem where we had like 10 and then 9 as a maximum length for an array. We're trying to look at it for input, but it still can be pretty large. So we definitely want to try to use a pretty good solution here. And then S consists only of printable ASCII characters. Alright, so this problem is actually pretty simple enough. So we can definitely try to use a 2-pointer solution. So we're going to implement our plan section here. So before I talk about how we might want to structure our algorithm, I want to start off with explaining the two pointers algorithm, since this is the first video that I'm going to be doing in this set of problems. All right, so two pointers is basically you're basically setting left and right numbers, which is going to be either index 0, that's both index 0, or 1 at index 0 and 1 at the last index. So that's the two most common ways to set up a two pointers algorithm, which is to set both pointers equal to 0, or have one pointer equal to 0, and the other pointer be equal to length of array minus 1. All right, and then oftentimes there's some logic involved. While left is less than right. We may implement the right logic depending on the problem, and then return the proper value. It's pretty simple, honestly. So I will definitely try to implement a solution to a more basic palindrome problem, just so you guys can see how exactly this works. All right. But that's pretty much the general structure of the two pointers algorithm. You have left and right pointer. For this problem, we're going to be using two pointers at different places, one at the first index and one at the last index. We make the right index move to the left and the left index move to the right. We stop when either they are equal or the left pointer becomes the right and the right pointer becomes the left, basically. So allow me to outline the algorithm here. So we're going to set our left pointer to 0, and then set the right pointer to length of s minus 1, so we can get the last index properly without going into a runtime error. And then we do a loop while left is left and right. We'll start off with a really basic logic with checking with palindrome or not, which is basically checking to see if the two letters are going to be equal. So let's say s left equals s right. We're going to perform a check on this. And if we do, we're just going to increment left and then increment right. Take that back. Decrement right, because we want the right going to the left. All right. And if they're not equal, we return false, because our pointers have to be equal, and if they're not, it's not going to be a palindrome. That's simple. All right. And if we manage to make it through the entire loop without running into unequal letters, we're going to return true. All right. So that basically explains the basic logic of the two pointers algorithm. We have left and right pointers. We set the left pointer at 0, set the right pointer at the last index. We'll loop through, make the condense. Once they overlap, we're done. if we run into the situation where the elements at the 2 pointers are not equal, then it's not a palindrome. But that's basically just how you. How you evaluate a string such that it only consists of letters and numbers. For the problem that we are facing with here, we may have any sort of like printable ASCII characters. So notice that there's commas, spaces, colons involved. So, Paul, yeah, we're not taking these into consideration. We will have to remove all non-alphanumeric characters. All right. So we're gonna do a few quick edits. So we first check to see if left is not alphanumeric, and if it's not, we increment left. There's actually a built-in function in Python that allows us to check whether or not a character is alphanumeric or not. It'll help. So we're going to be using that to save us some time. We next have to check to see if right is not alphanumeric. And if it's not, we increment right. I did it again. Decrement right. All right. And then one more check we want to implement here. If we run into letters, they need to be. We do not care if letters have letters are the same letter but in different cases. So it asks us to convert all the uppercase letters into lowercase letters. So we want to convert these into lowercase letters. Should we run into this situation here? I mean, because notice that this is a capital A and this is a lowercase a, but it's still read as a palindrome. So the output returns true. Okay? But yeah, pretty simple solution, and pretty convenient too. I mean, worst case time complexity is going to be O of n. It might be a little bit less than that, less than that, but we're assuming worst case time complexity here. And then space complexity. I mean, this algorithm is pretty convenient because we don't even need to worry about like implementing certain data structures like a hash map or set like we did in the past few problems that I did. So no extra data no data structures to add here. So all one space complexity. Terrific. All right, let's see if we can try to implement this in Python. So as a reminder, yes, I am going to be doing my solutions in Python. However, if you are a C++ or a Java programmer, I will be posting solutions to this problem in the comment section below this video. So definitely check those out if you want those other videos instead. So when we left, right equals 0 and length of s minus 1. Right? We next check. We loop through while left is less than right, and then what was the alpha num function again? Numeric function again? is al num. Okay, gotcha. So we do. So we call if not. What is it? SL dot is al num. So basically, this checks whether if our character at index left is going to be alphanumeric or not. All right. And if it's not alphanumeric, we can't use it for comparison, so we have to increment left. And the right pointer is not alphanumeric. We decrement our right pointer. Yes, I did it right this time. All right. And then we check to see if S left, make sure it's a lowercase. It must be equal to the character at index right, in lowercase. And just for clear, this doesn't affect digits. All right. So we keep going. We increment. We do both increment left, decrement right. And then otherwise, if we found out that the two letters are not identical, we must return false. All right. And then lastly, we managed to make it through the entire loop. We're going to return true. Let's test this, see if this works. All right, perfect. Does it pass all the test cases though? Yes, it does. Indeed it does. So yeah, O(n) time complexity, O(1) space complexity, 2 pointers and pointers is the best solution, and it is extremely helpful for, solving problems like this. With this, so glad we were able. Glad we knew 2 pointers, because it would be pretty difficult to perform checks on all the letters or not if we didn't know this algorithm. I mean, it'd still be doable, but it'd probably take a lot of work, and it might take up a little bit more time, and we definitely have to loop through n times. See, this here actually might run select strings, maybe just even like n divided by 2 times. Like if the string is going to be all alphanumeric characters or whatnot. So the 2 pointers may actually save some time in certain instances. So again, extremely helpful with the time complexity situation here. So yeah, I guess that's it for today. Thank you so much for watching. Be sure to subscribe to my channel for more video walkthroughs of these LeetCode problems. No problems. And don't forget to check the C++ and Java solutions in the comment section below this video if you would prefer to see the solutions in those languages. All right? We'll go through another 2 pointers problem tomorrow. Probably going to be a little bit more difficult than this one, but, it'll do. Okay, but again, thanks so much for watching, guys. So long.